Welcome to the Student Brand. This is our Shiva sir. Today we are going to discuss about light reflection and diffraction chapter. So problems we are going to discuss in this chapter. So exclusively problems we'll discuss, right? Light reflection and diffraction. If you watch my previous videos, so in that I explained concept. So now I am going to discuss about light reflection. So refraction topic we'll discuss. So if you observe, I already explained the concept light reflection. Now we'll discuss problems related to light reflection and refraction. So in the previous class, I given one problem. Related to light reflection. So how many members solved? So if you know, let me. If you solved, let me know. Those who solved, you can check once. If not, anyway, I will explain that topic. You can check once. It's also fine. Okay. Right? Yes. So that is about Student the Brand channel. So myself, I am Shiva sir. Today we are discussing about light reflection diffraction chapter problems. So welcome to my class. So an object. Okay. So can check the question. An object in size is placed at 25 centimeter in front of a concave mirror. So a concave mirror is placed. An object question. An object 4.0 centimeter in size is placed at 25 centimeter in front of it in front of a concave mirror. So a focal length 15 centimeter at what distance from the mirror should a screen be placed in order to obtain a sharp image so question mark. Find the nature and the size of the image. So this is the question. This is a question you can see here. This is the question you can observe. An object in size placed at 25 centimeter, so in front of a concave mirror. So you have to underline what are the given values. So once you read the question, everyone, so read the question and try to answer it. So I hope it is very clear. An object is 4 centimeter in size, so is placed at a distance in front of a concave mirror. So object is placed in front of concave mirror, right? Yes. So placed. Concave mirror, focal length is given. Height of the object is given and focal length is given. At what distance from a mirror should the screen? Means image. They are asking to find out image distance. Okay. So find out the image distance. To obtain sharp image. So they are asking to find out image position. Find the nature of the nature also we have to find out, and the size of the image. Can anyone know? Can you tell me? So how to do it? So height of the object is given, object distance is given, focal length also given. So we have to find out V. So by finding V, so we can substitute we can find out in easy way, right? So just check one. So here you can understand. So you have to understand one thing. So an object size. So this is the size of the object, means height of the object. So you have to underline height of the object. So an object in size means height of the object. So in size it is placed. So you can see in size it is placed, right? Means height of the object. So at 25 centimeter, so means 25 centimeter, that is nothing but object distance, U, in front of a concave mirror. So we have to understand the concave mirror. What is the mirror given? That we have to understand. That is a concave mirror. So focal length also given. So what is the focal length? 15 centimeter. Focal length is 15 centimeter. So focal length also 15 centimeter. At what distance from the mirror should a screen be placed? So should be a screen be placed. Screen is nothing but image distance. We have to find out image distance, question mark. Indirectly they asked about image distance. So be placed in order to obtain a sharp image. Find the nature and size of the image. So size of the image is nothing but so what is size of the image? Height of the image. So they're asking, and nature. So what is the nature? So real or inverted or virtual erecta. Okay, so real or virtual. So that also we have to find out. Real or virtual we have to find out. Okay, so that is a question mark. So like that, if you underline like that, in this way, in this manner, if you identify the question, we can solve in easy way. Okay, so we can solve this type of questions in easy way. So try to check it once. Try to identify. So this is the way to solve the problem. Okay, so now you can check. An object, height of the object is given. So how much? 4 centimeter height of the object. So in size is placed at distance how much? 25 centimeter. Distance how much? 25 centimeter. 25 centimeter is given. So now you can write the given data. So first of all, write the given data. So we can write given data, solution, given data. So I'm writing given data. So first one, we can take the values. Height of the object is 4 centimeter, 4 centimeter. And next one, object distance is given. Object distance is given 25 centimeter, 25 centimeter. And focal length also given. Focal length is 15 centimeter, 15 centimeter. Now we have to find out image distance and one more point is size of the image, so height of the image. So this is the question. Now you can understand identifying. First you have to identify the data. What exactly it is, what they given. So here once again, an object 4 centimeter in size means height of the object is placed at 25 centimeter. 25 centimeter means object distance. 25 centimeter means object distance. So that is object distance. We have to think about that is object distance. Object distance is 25 centimeter in front of a concave mirror. So we have to underline this word. Very, very important. This word is very important. What is that? Which mirror is given? Which mirror is given in the problem? That is very important. You have to understand which mirror is given. You have to identify what is a mirror. What is a mirror is given in the problem. So what is a mirror? Concave mirror. What is a mirror? Concave mirror. What is a mirror? Concave mirror. Concave mirror, concave mirror, concave mirror. Keep in mind concave mirror. So when you are taking the sign conventions, you have to keep that mirror in mind. Okay. So by taking that mirror, so we can take the sign conventions. So keep that one. So focal length. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Find the nature and the size of the image. So now you can see object distance anyway. Object distance always negative. So what are the conditions it is? What are the possibilities are there? Object distance always negative and focal length is negative. Focal length is negative. Okay, so by taking these points, so we can solve it. By taking these points, we can solve it. So now you can see, so 1 by f equal to 1 by v plus 1 by u. So from this we can take 1 by f equal to 1 by v. How much? 1 by v you have to find out. 1 by f also given, right? Focal length is given. Focal length how much? Focal length is also given, right? Focal length is 15. Focal length is 15. So you can see focal length. So what is how much is the focal length? Focal length is 15 minus 15. Oh sorry, focal length minus 15, right? Yes, here you have to place. So 1 by minus 15 equal to 1 by v plus 1 by minus 25. Object distance is minus 25. So now 1 by v equal to 1 by 15 minus 1 by 25. So you can take LCM. How much is the LCM? If you are taking LCM, so 15, 25 LCM. So I am doing in the right side. So 15, 25. So 5, 3 ja, 5, 5 ja. 25, 3 ja. 75. So 75 I am taking here. So 15, 3 ja. 15, 15, 5 ja we can take. 25, 3 ja. 25, 3 ja, right? Shall we take like that? Shall we take? Focal length is negative. If it is go that side, object distance also negative. 1 by v equal to, so we are taking the values. Mirror formula. Focal length is 15, object distance 25. So image will form real and inverted. So any mistake? Focal length is 15, correct only, right? Mirror formula 1 by f equal to 1 by v plus. So 1 by f equal to 1 by v plus 1 by u. Okay, we have to find out v value. Okay, focal length is already here only, right? So we are taking 25 to that side. 25 to that side, right? 25 we are taking 25. See here, you need to understand one thing is, so we need to take 25. So this value are taking this side, this value are taking this side. So that is 1 by 20, 1 by v equal to 1 by 25 minus 1 by 15. Same thing only, but here this value is going because we need to find out v value, right? So v value we have to find out. So that is the reason we are considering. Now we can take. So how much is the LCM? LCM is 75. LCM is 75. So here this is 3 and this is 5 by 1 by v. So v 1 by v equal to minus 2 by 75. Minus 2 by 75. Minus 2 by 75. Correct? So minus 2 by 75. So now we want v value. We want v value. So from this v value equal to reverse 75 by 2. 75 by 2. So 75 by 2 how much? 75 by 2 how much? Can anyone say? 75 by 2. So minus 37.5. So centimeter, because everything given in centimeter. Correct? Just check once. Check once. Any doubt? Next one. We got. Next one more. We have to find out the height of the image. So height of the image equal to magnification equal to height of the image by height of the object equal to minus v by u, because it's a mirror. Mirror formula is minus v by u. Mirror formula is minus v by u. Okay, mirror formula is minus v by u. So height of the image is how much? Height of the image. Height of the image I am considering. We don't know height of the image. So let it be height of the image. You can write minus v by u into height of the object. So now you can see object distance. Image distance is this one. So we can take minus 37.5, and height of the object is 4. Height of the object is 4 by height of the object distance is minus 25. Object distance is minus 25. Now you can solve and tell. How much you got. How much you will get? Can you solve and tell me? Anybody? Can anybody tell the answer? The answer is height of the image. Height of the image is minus 6 centimeter. This is the answer. Now you see. So this is the method we have to follow. This is the way we have to do it. So once again, I will explain. Just check once. If you have any doubts, you can ask. Sir, how? See, while taking these values to that side also, we have to take care about sign. Sir, whether we are doing correct or not, how can we check? Okay. So here, this is the object distance. Object distance is this one. So draw the image formation. If you draw the image formation, you'll get it. So if you draw the image formation, you'll get it. So I'll draw the image formation for this case. So you can see. So I'm taking like this. I'm considering like this. Okay. So now you can see this is the pole, focus, center of curvature, pole, focus and center of curvature. Now object distance. Oh, that is a convex or concave mirror? What is mirror? What mirror is given? Concave mirror is given. Right? Yes. So now you draw the concave mirror. Yes, I am drawing concave mirror. So here is the pole, focus, center of curvature. So object is at 25 centimeter. Object. So focal length is 15. Focal length is nothing but here. Focal length is here 15. This is a 15 focal length. 15 centimeter. Object distance is 25 centimeter. So this is 30. From here to here is 30, right? So here to here is 30. How? because focal length is 15, right? So object is must be here between C and F. If the object is placed between C and F, where image will form? Beyond. So beyond this point means more than C. This is 37.5 is more than C only, right? More than C only, right? Yes. So then our diagram is correct. Our problem is correct. Our calculation is correct. Like that we can check. We have to check. We have to check the problem, right? Shall we check once? Okay, so note down the problem. So note down the problem. If you have any doubts, you can ask me. So those who have any doubts, you can ask me. Otherwise, we'll go to the next problem. Next problem is very, very important. Same problem itself, same method. An object size is 7 is placed 27 inches of a concave mirror focal length. At what distance from the mirror screen be placed so that sharp image focus? Okay, same thing. Same thing. So height of the object is given and object distance is given, focal length is given. We can find out same method, one more problem I'll give. So if you have any doubts, those who have any doubts, you can let me know. So one more method I'll give. One more problem. Shall we do one more problem related to this only? Okay, done. So next same method. So same problem. Same problem. Same method. Same method. Values are changed. I'll give the problem. So just check once. Okay. So same method. So previous method only, same method I'm saying. Same method. Same method. But values are different. Values, small change in values. So check once here. I'm taking. So problem. Height of the object is given. Height of the object is 7 centimeter. And object distance is given 27 centimeter. 27 centimeter. And concave mirror only. Mirror is concave mirror. Concave mirror. Concave mirror. And focal length is 18 centimeter. 18 centimeter is given. And at what distance the screen should be placed? At what distance the screen should be placed? Okay, so show that focused image. So image we have to find out. So here image distance they asked. Show at what distance from a mirror should a screen be placed so that a sharp focused image will form. Well, this time they are asking about only image formation. So now we will see. Okay, so here for concave mirror, object distance is negative, focal length is negative. So formula is 1 by f equal to 1 by b plus 1 by u. 1 by f equal to 1 by b plus 1 by u. Now focal length is given. How much? Focal length is minus 18 equal to 1 by v plus object distance is by minus 27. Minus 27. So I want 1 by v you are taking. So this value you are considering this side. So you are taking the value that side. So 1 by 27. Correct? So focal length, object distance you place. So we need to find out v value. So v value. So take this value this side. Then we can get 1 by 27 minus 1 by 18. So LCM. LCM how much? How much is the LCM? So 54 or what? So 27 and 18. Okay, shall we go for 9? So 3, 2. Okay. 18 3 ja, 27 2 ja. So now I am considering 54 here, 27 2 ja, 18 3 ja. So then we get so 1 by v equal to, so minus 1 by 54. Minus 1 by 54. So that is the value. Now we can take, so v value is minus 54. Minus 54 centimeter. V value is minus 54 centimeter. That's enough. So screen must be placed. So if you want to check the diagram, whether we did correct or not. So for checking the diagram, so checking the problem, we need to draw the diagram. So draw the diagram like this. So I'm taking a concave mirror. This is a concave mirror. Here is a pole, focus, center of curvature, pole, focus and center of curvature. Here object is placed. So where the object is placed? So focal length is 18. So this is 18. Okay. This is the 18 centimeter. So next radius of curvature is 36. So this is 36. So 36. Okay, 36 centimeter. So between 27 means between C and F. Between C and F, object distance is placed here. Object is placed. Where image will form? Beyond center of curvature. Beyond center of curvature is nothing but 54. So this is the distance between object to pole is 27. Object to pole is 27. So if 54, so here we can take here. So this is the value. The distance between pole to image. Image is 54. Image is 54. Real and inverted. Real and inverted. So image is correct. So image is correct and problem also correct. Like that we have to solve. Like that, in this way we have to solve the problem. So is there any doubt? If you have any doubt, you can ask. So we can go to the next one. So if you don't have any concerns, so we'll go to the next problem. Next problem is list of sign conventions. They said list of sign conventions. So very important. So many times they will ask this question. Question is, list the new quotation sign conventions for reflection of light, a spherical mirror. Draw a ray diagram and apply these conventions for calculating the focal length and nature of spherical mirror, which forms 1 by 3 times of magnified virtual image of an object placed 18 centimeter in front of it. So we have to find out that one. Okay, so that's enough. So that we can try. Next one, I'm going to the next problem. An object height is given. Object height is given, placed at a distance 9 centimeter. Object distance given. For concave mirror, focal length also given. We have to find out calculate position of the image. Position of the image we have to find out. Okay, see. So we can go with that. So focal length is 18 centimeter. Then calculate the position of the image. Calculate the position of the image. Position of the base formed. Okay, so this is the question. This is the question. You can see an object 3 centimeter height is placed at a distance. An object is placed. So 3 centimeter. So here 3 centimeter is given. 3 centimeter if you are taking, so we have to underline 3 centimeter high is placed. So 3 centimeter height. So this height of the object is placed at a distance of 9 centimeter. So this is the object distance. Object distance is given u value from a concave mirror. So this is a concave mirror. So concave mirror we can understand. Focal length. So focal length is given. Concave mirror focal length is given. Calculate the position of the image. So image position they are asking. So we have to find out. So v value. So that is a question. We have to find out the question like this way. Okay, every time whenever you are reading, first you have to check. So whether what are the values they given, so what is the sign conventions, everything we have to note down. Okay, so you have to identify the first. You have to identify the data. What is the data given? In the question? Okay, so I hope it is the question. That one is the question. You can check once. Right? Now will you solve? So try to solve. Now I am taking given values, given data. So I am taking the given data. So height of the object is given. So height of the object. What of the object? Height of the object equal to 3 centimeter. And second one, object distance is 9 centimeter. Concave mirror. Focal length also given. Focal length is minus 18 centimeter. Focal length is 18 centimeter. So we can say focal length is 18 centimeter. And calculate the position of the image. So image position we have to find out. So that is the data they given. So you can check once. Now formula is 1 by f equal to 1 by v plus 1 by u. 1 by f equal to 1 by v plus 1 by u. So now object distance anyway negative. Object distance always negative. I am considering here focal length also negative because it is a concave mirror. If it is concave mirror, compulsory you have to take negative sign. I am considering this a concave mirror. Like this. So pole, focus, center of curvature, everything we have to consider. Pole, focus and center of curvature. So this is the pole. Aditya Singh and Neymar. Hi, both of you. So I am taking this the pole, focus and center of curvature. So now you can see substitute the values. 1 by minus 18 equal to 1 by v plus. So object distance is minus 9. So here this is the object distance and focal length. These two values you can substitute. So substitute the values, then 1 by v equal to so take 1 by 9 value this side, then thank you so much. So 1 by v equal to 1 by 9 minus 1 by 18. So LCM is 18. So 2 minus 1, that is nothing but 1 by v. 2 minus 1, correct? Correct only, no? Yes or no? Then, so if I do anything wrong, let me know. So 18. So then v equal to positive or negative? Positive. Why we got positive? What is the reason? So positive sign we got. Whatever we did correct or not, I'll check. So checking, first compulsory we have to check what are you did the problem, so whether you got correct answer or not. So by checking, by taking the values, you have to draw the diagram. After drawing the diagram, whether you or what by comparison of these values, the final answer, final image is whether you are getting correct or not, we should understand. So for that, see, for solving the problem, so data and science, next diagram. These three are very important. First, you have to take the data. We have to write the data. What is the data given? Second, sign. So sign convention, according to sign conventions. According to sign conventions, you have to take the sign conventions. Third one. So third one, we can go for you can go for image formation. So now I am taking this focal length is 18. So check the focal length is much 18. So I'm considering 18. 18 is the focal length. Anyway, for concave mirror it's negative. And object distance. Object distance is 9. So 9 is nothing but, so object must be placed here. Object is placed here. So when you place the object, the image will form behind the mirror. That is virtual erect and enlarge. So object position is positive because in the direction of incident rays we are taking. So whatever we got, the answer is correct. So star marks. We got correct answer. 5 star. Okay. So please. V is positive only. Why V is positive? So according to sign convention, new Cartesian sign convention, new Cartesian sign convention, all distance measure from the pole. Distance are positive along the incident rays. Distance are negative opposite to incident rays. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention, new Cartesian sign convention. So actually, so this is song of subject only. Sign convention, for remembering sake, I converted in the form of song. So same thing. So all measurements we have to take from the pole. So all measurements we have to take from the pole in the direction of incident is positive, opposite incident is negative, above the principal axis positive, below the principal axis negative. So 4 points. If you remember the 4 points, you can do any problem. Sign conventions are very, 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 very important for solving the problems. Here that only, right? Object distance is positive. So that only. After getting the positive sign only, I checked whether it is correct or not. Yes, after taking the values, object distance, image, object distance and focal length, and according to the image formations also you should keep in mind. Now, so read the question, identify the data, read the question, identify the data, write the data, given data, take the sign convention, use the formula, substitute the values, and after getting the final result, you must check, you have to check without any doubt, compulsory you have to check whether you are getting correct answer or not. So after checking, if you are getting correct answer, so see, while we doing problems, there is a kick. There is a no who will experience, for them only it will they can get to know. The point is, if you are taking the problem, okay, so you are going through the process. At the end, you got correct answer without any mistakes. If you got the correct answer, okay, by following the process, without going for a rechecking, many times no need to check. One time if you check, if you get the correct answer, then that feeling will gives goosebumps. Okay, na? So that is next level. Okay, come to the points. I hope you got the correct answer. So that's enough. So once again, I'll explain the problem. Listen carefully. An object is 3 centimeter high, is placed at a distance. Here we didn't use this one, but whatever the data is required for doing the problem, that's enough. So no need to take extra data. So here an object is 3 centimeter high, is placed at a distance of 9 centimeter from a concave mirror. See, underline points. So height of the object and object distance, concave mirror. So what are the required values? So our focal length is f, and calculate the position of the image. So here question mark. So by seeing the question itself, you will get the formula. You don't need to go for solving also. You don't need to go for solving by seeing the given data. So if you write in this way, so you don't need to go for answer. You don't need to go for answer. Not required also. This much also not required. By seeing this data only in your by roughly also you can tell the answer. You can tell the answer. So that is a simple way, easiest way so to solve the problem. Name the type of mirrors used in the design of solar furnace. Explain how temperature is achieved by the device. Hi Neymar. Solar furnace concave mirror. When the light rays falls on it, it will converge and meet at one point at the focus. So this is the first case. Concave mirror first case. Light rays are coming from infinity. After reflection, light rays will meet at one point. That is focus. So there, solar furnace will be placed. So that will collect the sun rays by the this photo voltaic effect. There is nothing but suitable charges will fall on it automatically. So the movement of the charges, the movement of the particles takes place. By that we can get the current. So I hope that is the process. Any doubts still? Okay, chalo. Then we can. Okay, so thank you. If you like this video, if you like the content, so say one thank you and click on like button. That's enough. Okay, sir, we go to the next one. So I'm going to the next problem. So try to solve it. An object is placed. So I hope it is clear to you, right? If you want, you can say. Actually, each and every question, it's like a diamond. It's like, see, the letters and the format. So every time I want to rub, but I can't able to erase. That's a concern. Because when you keep your all efforts on one work, so definitely it is a worthy. So do your hard work, do your best, definitely will get succeed. So day one or one day. Day one is now, so one day you will get it. Now is your day, you work, do your work so hard in silence. Let your success will define you. Quotations are very good, quotations are excellent, quotations are very good. So when you are doing the work, sometimes we can't able to understand. So by saying the quotations are very simple, very simple. Quotations are very simple. My name is Himanshu. Oh, sorry. According to the name I called, actually I generally I will ask by saying that one. I will ask the student name. So what is your name? So sorry for that. Sorry for that, Himanshu. Yes, actually he's a football player, right? Neymar. So Ronaldo friend, I hope like that. Okay, come to the point. Next one. Yes. So then an object is placed. Question. An object is placed. An object is placed. An object is placed. All distance measured from the pole. Distance opposite along the incident trace. Distance negative opposite to incident trace. Virtual image of the object. Virtual image of the object. Object is placed, is obtained. Object is obtained at a distance of at a distance of at a distance of at a distance 20 centimeter from the mirror from the mirror from the mirror. Calculate 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 the position of the calculate the position of the position of the object. So now you can see, now we can see an object is placed in front of concave mirror. Underline, start underline. An object is placed in front of concave mirror. Object is placed in front of concave mirror. Focal length is 30 centimeter. F, we have to identify F. The virtual image of the object is obtained at a distance of 20 centimeter. So virtual image. So image distance also given from the mirror. Calculate the position of the object. Oh my God. Position of the object they asked. Position of the object. How to do it? Position of the object. Calculate the position of the object. So given data is given. So you can see now, focal length is how much? Focal length is 30 centimeter. Is it positive or negative? Negative. Virtual image distance is 20. Is it positive or negative? Positive, because virtual image from the mirror. Calculate the position of the object. Object we have to find out. Object anyway positive will get. Now you see here. Now you have to understand one thing. Focal length is negative, always negative. And now you can see 1 by f equal to 1 by v plus 1 by u. 1 by f equal to 1 by v plus 1 by u. So 1 by f equal to 1 by 30 equal to minus 30, and 1 by v is nothing but 20 plus 1 by u value. Okay, so 1 by v value, so you can take this value this side. 1 by u equal to 1 by minus of minus 20 will get. So both minus will get, right? Both minus 1 by minus 20 minus of 30. So object distance 1 by u equal to, so how much is LCM? 60, right? 60 only, right? So 60 by 5. So we'll get 12. So u equal to minus 12 centimeter. Correct? 5 10 ja 5 yes. 5 1 ja 5 minus negative, correct only. So check whether you are doing correct or not. Check once. Whatever you did, correct or not, check once. How to check? Checking process is very important. Every time you are taking the mirror, pole, focus, center of curvature, pole, focus, center of curvature, object is placed, focal length is 30, means this is the 30 and 30. Object must be placed between F and P in order to get virtual image. Okay, this is the process. This is the process. Do you have any doubts? Do you have any doubts? You can ask. Otherwise, we'll go to the next problem. So this is the method to identify. This is the method to solve. So identify the problem and write the given data. Use the formula. Substitute the values and solve it. Okay, done. So thank you. So just check once. If you have any doubts, let me know. I'm going to the next one. Calculate the position of the object. So object distance only they asked to find out. So we found. So a convex mirror used as a rear view mirror. Question is, a convex mirror is used as a rear view mirror. Okay, so we have to find out what we have to find out. We have to find out image distance. Correct? Anybody? So a convex mirror, so you have to underline the convex mirror. Which mirror it is? Used as a rear view mirror in car as a radius of curvature. So radius of curvature is given, R value is given. R value is given here. R value, this is the R value. This is the R value. Okay, this is the R value. And if an approaching is bus is located at a distance of 5. So bus is given, that is nothing but object distance. Object distance is given, radius of curvature from this mirror. How far its image appears in the mirror. So image, so they are asking to find out image. They are asking to find image. So we have to find out V value. So for that, so we can write, we can draw the first take, write the given data, given data, given data. Given data. So here in this problem, what is the given data? So radius of curvature is given. Radius of curvature. So what is the radius of curvature? How much? Radius of curvature is 3 meter. Radius of curvature is 3 meter. And bus is located at a distance they mentioned. Bus is located in the sense object distance. Object distance. Object distance positive or negative? Always positive. Always positive. That is 5 meter. Because whether it is convex mirror or concave mirror, whatever it is. So whether it is concave mirror or convex mirror, so pole, focus, center of curvature, pole or focus, center of curvature, whatever it is. So always you have to take negative because object must be placed in front of the mirror. According to the sign conventions, object distance is negative. According to the sign conventions, object distance is negative. So now formula we can use. So formula for mirror formula. Mirror formula we can use. What is the mirror formula? 1 by f equal to 1 by f equal to 1 by v plus 1 by u. 1 by u. So now you substitute the values. So 1 by f equal to 1 by f equal to, now we can take 1 by v value. We can find out, right? We can find out f value. How we can find out f value? How we can find out f value? Anybody? So they didn't give f value, but they given one value. From that we can find out. From that we can find out f value. From where we can find out f value? So we can find out from radius of curvature. From radius of curvature we can find out here. Radius of curvature is given 3. Radius of curvature is given 3. So r equal to 3. So r equal to 2f. So 2f equal to 3. So f equal to 3 by 2. So keep it like this. Keep it like that. Convex mirror is focal length is positive because so the focal length will be here. The focal length is in this side. So according to the sign conventions, focal length is positive for convex mirror. Focal length is positive for convex. Convex mirror focal length is positive. Convex mirror. Convex mirror focal length is positive. So accordingly we can take positive sign. So accordingly, according to the mirror, so we can take positive sign. Positive sign. So f equal to positive. F equal to plus 3 by 2. F equal to plus 3 by 2. Now you substitute. So 1 by b value we have to find out. So we can see Vipin, hi. What is your name? Vipin only? Vipin Joshi. So 3 by 2 by 1 by v have to find out. So object distance how much? Minus 5. If it is comes this side, so if it is comes this side, So if you are taking V value this side, then 1 by V equal to 1 by 5 plus 2 by 3. So if you are taking LCM, by taking LCM, what is LCM? 15. So here 3 plus 5, 5 into 2, 10. Okay, then 1 by V equal to 1 by V equal to, so 10 for 10 plus 3, 13 by 15. So V equal to 15 by 13. So then we'll get what is the V value? Can anybody say what is the V value? V value is 1.15. 1.15 centimeter meter, because radius meter, object distance meter, then even everything. So meter. So this is the answer. So check once whether we did correct or not. So object distance is, so here from here we are taking like this. So one lighter I am taking like this, another lighter I am taking here. Image formations, they will ask for 3 marks. Image formation 3 marks. This problem for 3 marks. This problem also for 3 marks only. Image formation and problem. So 3 marks they will ask. Oh, very good. Congratulations. So I am taking here. So through the focus. So image will form. Image will form between here. Image will form between P and F. Image will form between P and F. Okay. So here focal length is how much is given? 1.15. You will get from here. We can take 1.15. 1.5. Sorry. So 1.5 plus 1.5 is 3, right? So we'll get 1.5. So this is 1.5. 1.5. Okay. So between this value, between 1.5 only, we got V value, that is 1.15. So our answer is correct. Our problem is correct. Our values are correct. The process is correct. Everything is correct. Any doubt? You can check once. Once again, I will explain the problem. Once again, I'll explain the problem. You can check once, everyone. So shall I go to the next one? So if you are there, let me know. So I'm going to the next problem. I am going to the next problem. Okay. So maximum these are the problems are there. So we are going to the next one now. Few more problems are left, but still we can go to the next refraction topic. I'll explain refraction topic, light refraction. So when the light is passing from one medium to another medium, the bending of the light at the interference of the two media, the path of the light changes at the interference of the two media is called refraction. The path of the light changes at the interference of the two media is called refraction. If you are new to the channel, do like, share and subscribe my channel. So you'll get the content. So grade content. Okay. So from light from CBSE grade 10 physics. If you have any doubts, you can ask me. So you can message, you can contact, right? So that is about. If you need classes, you can contact this number. So WhatsApp number is available here. So you can contact that number. Right. So now I'll explain about refraction phenomena. Refraction phenomena. So I'm taking when the light is passing from one medium to another medium. The light is passing from one medium to another medium. So light refraction. Light refraction. Light is passing from one medium to another medium. The light is passing from one medium to another medium. So I'm considering here. So this the surface interference. So this is the rarer medium, and this one is the denser medium. This is the rarer medium, denser medium. If the light ray is passing from one medium to another medium, so the bending of the light at the interference of the two media. The bending of the light at the interference of the two media is called refraction. So what is a rarer medium and denser medium? Rarer medium is nothing but speed of light is more in the medium. So that is rarer medium. So best example we can take air and speed of light is less. So in the medium, that is denser medium, and water also we can say. Speed of light is more in the medium. So we can take air and so if you comparison between air and water. If you compare between water and glass, so air and water, air is a rare medium. Water and glass, water is a rare medium. Like some other substance, if you take, it depends. Some other substance, if you take, it depends. So here I am considering if the light ray is passing from rarer to denser. If the light ray is passing from rarer to denser, I am taking this normal line. So it bends towards the normal line. It bends towards the normal line. So this is incident ray. Incident ray, and this one is the refracted ray, and this one is I'm considering normal line. The path of the light changes at the interference of two media is called refraction. So if the light ray is passing from denser to rarer, so I'm concerned this is a rarer medium and this one is the denser medium. So this is the normal line. If the light ray is passing from denser to rarer, it moves away from the normal line. If the light ray is passing from denser to rarer, it moves away from the normal line. Okay. So here the angle between incident ray and normal line is called angle of incidence. Angle between incident ray and normal line is called angle of incidence. This is the angle of incidence. And angle between refracted ray and normal line is called angle of refraction. And here this is the angle of incidence. And this one is the angle of refraction. So the angle between incident and normal line is called angle of incident. Angle between refracted and normal line is called angle of refraction. Angle between incident and normal line is called angle of incident. Here also, here in this case, if it is passing from rarer to denser, so angle of incident, in this case, angle of incident is greater than angle of incidence. Angle of incident is greater than the angle of refraction, because whenever the light ray is passing from rarer to denser, it bends towards the normal line. Okay, so bends towards the normal line or moves towards the normal line, towards normal line. Okay, towards normal. So whereas here in the second case, if you are taking second case, so angle of refraction is greater than the angle of incident. So angle of refraction is greater than the angle of incident. Second one, so moves away from the normal line. Away from the normal line. Away from the normal. So that's enough. Okay, so these are very, very important. So the bending of the light at the interference of the two media is called refraction. If the light ray is passing from rarer to denser, it tends towards the normal line. If the light ray is passing from denser to rarer, it moves away from the normal line. It moves away from the normal. If it is passing from rarer to denser, it moves towards the normal. If it is moving from denser to rarer, it moves away from the normal line. Okay, so this is about refraction. So then we can go to the one more. Okay, laws of refraction. Laws of refraction. In this case, laws of refraction are laws of refraction. So I'll explain with the help of one diagram. So laws of refraction. Laws of refraction. Okay. So laws of refraction is nothing but Snell's law. Laws of refraction or Snell's law. If they ask in the exam, laws of refraction. Define laws of write about laws of refraction or so define Snell's law, like that they will ask. Define Snell's law. Okay. So now we will discuss about the laws of refraction or Snell's law. So what is that we will solve. Now you can see. So incident ray, reflected ray, normal line. So this is the incident ray, refracted ray, incident ray, refracted ray, normal line lies on the same plane. And say second point is sine of angle of incident to sine of angle of refraction equal to constant. Very, very important. Sine of angle of incident to sine of angle of refraction equal to constant. Sine of angle of incident to sine of angle of refraction equal to constant. This is also called a refractive index. N is the refractive index. N is refractive index. Refractive index. Refractive index. Okay. So if the light ray is passing, so I am taking this a medium 1 and a medium 2. So medium 1 and medium 2. If the light ray is passing medium 1 to medium 2, so refractive index of medium 2 with respect to medium 1, N2 by N1. So that is nothing but V1 by V2. So why we are taking? So normal refractive index if you are taking N equal to C by V. So speed of light in vacuum by speed of light in medium. So that is called absolute refractive index. Absolute refractive index. Absolute refractive index. Absolute refractive index is absolute refractive index. Refractive, absolute refractive index. So index. So this is the relative refractive index. Relative refractive index. Relative refractive index. So absolute refractive index is nothing but refractive index. So absolute refractive index is nothing but speed of light in vacuum by speed of light in medium. Relative refractive index is speed of light in medium 1 by speed of light in medium 2. Speed of light in medium 2. So if you are considering N12, so we can also write in this format N12. So this is very, very important in the problem. So in the MCQs, MCQs very, very important. So make sure that you are remembering this one. Either we can write in this way or in this way also. Both are equal. Okay, any one we can write, any one we can follow. Any one we can follow, right? Sir, back again. If incident angle is denser such that the refractive angle 90 degrees grazing surface and come out in the rarer medium, it is known as critical angle. Oh, hi. Hi, Soham. Thank you so much for joining. So keep joining and keep motivating, keep answering, keep questioning. So I am always grateful for your presence. Critical angle is sine inverse of. Yes, definitely. Okay, so this is extraordinary concept. So very, very important concept. So try to prepare, try to practice. Definitely one question will come related to this one. So 2 marks question, 2 marks question one will come. So related to problems only, problematic question one will come. And here 3 questions. Question number 1 is related to definition of refraction. Definition of refraction, one question will come. Snell's law, explain about Snell's law, one question. And third one, absolute refractive index. Fourth one, relative refractive index. And related to this one question I will give. So that is N. So I'll give one question. MCQ's point of view, very, very important. So on MCQs, I will give most important high weightage MCQ from this concept. From this concept, that is, so what is the value of this? What is the value of this? So if you tell, that is great. Anyone can tell the answer? Anyone can tell. So let me know the answer of this question. Answer is 1. Answer of this question is 1. Hey, King Gamer. Hey, hi. Very good. What's your name? King Gamer. So don't mind. So I want your name is, I don't know, right? That's why just it is there. Naveen Kumar Das, sir, lens makers formula. Sir, lens makers formula. Yeah, definitely I'll discuss lens makers formula, but it will take time. It will take time. So we are going to the concept. I'll explain. Naveen Kumar, Namman Kumar Das. Yes, I'll explain lens makers formula. So lens, everything. We didn't go. Still, we are not. We didn't enter into the lens. So after once entered, so definitely we'll do. Related to this, concept. Shall I explain problems related to this one? Actually, we are doing concept plus problems. So in the previous class also explained. Related to glass lab also questions will come. Light enters from air into glass having refractive index. So keep this one. This type of questions will come related to refractive index. 2 marks questions are very, very important. So shall I rub it? See, each and every concept is very important. Make a note of it. I am writing very clearly. So you can see, you can sense it. Okay. So I hope it is very clear, crystal clear. So very neatly I am writing. Make a note of it. Write in your book. So it will be useful. Okay. All the content. Definitely what we are discussing. So it is a worthy of class. So now I am saying, so I am writing. So try to answer the question. I will be okay writing. So light enters question. Light enters. Light enters from air. From air into glass. Air into glass. Air into glass. Having refractive index. Having refractive index. Having refractive index 1.50. What is the speed? What is the speed of light in glass? Speed of light in glass. Light in glass. Light in glass. Okay. So the speed of light in vacuum is the speed of light in vacuum is 3 into 10 power 8 meter per second. Full stop. Okay. So will you try? The digital. Hi. Soham. We solved it immediately. So done. Now can you answer it? Answer is so very good. Correct answer. What is your name? King Gamer something you said. Did you say your name? King Gamer. Can you let me know? Can I know your name, King Gamer? Soham anyway. Soham only. So he is my student. Anyway, you will tell the answer. What about remaining students? Ahmad. Very good, Ahmad. Keep it up. So, student of the class. So, our name is our channel name is Student the Brand. So, student of the class is Ahmad. So, answer is 3 2 into 10 power 8 meter per second. Correct, Ahmad. And Soham. Soham is always so be out of the box. I'm writing out of the box in the top place. Okay, Soham. Because this is my student, that's why already just currently and past, future, and present also is my student only. That's why I'm writing. Ahmad, very good, Ahmad. So you're getting 5 star. So not chocolate. So 5 star. Those who say correct answer will get 5 star. So let me know. So who did? We'll solve it. Now we'll solve it. Okay, fine. You can see. Yeah, light enters from air into glass having refract index. This is the refract index n. So what is speed of light in glass? The speed of light in vacuum is. So V value given. So now solution. Given data. So given data n equal to 1.5. So 1.50 or 1.5. And speed of light is V equal to C. So actually C we are finding. We have to find out C value. C value equal to, so 3 into 10 power 8 meter per second. 3 into 10 power 8 meter per second. So n equal to C by V. N equal to C by V. So n equal to 1.5. So C equal to 3 into 10 power 8. Speed of light in vacuum array. So V we have to find out. So let's okay. So cross multiply. If you cross multiply, you'll get it. So V equal to 3 into 10 power 8 by 1.5. So if you want to do it 3 by 1.5, directly also you can do it. So for understanding, so in a simple way, I am taking like this. So 30 by 15 into 10 power 8. 30 by 15 is 2. So we can take V equal to 2 into 10 power 8 meter per second. This is the answer. Answer Ahmad got, even Soham got. So is it correct? If you know the answer, so let me know. So whether it is correct or not, check once. Light enters from air into glass having a refractive index. What is speed of light in glass? So speed of light in, so we can also take speed of light in glass. Normally here this absolute refractive index. So anything with the comparison of speed of light in vacuum, then we can say absolute refractive index. So don't get confused between absolute refractive and refractive index. So if they ask, you can write this absolute refractive index only refractive index. So speed of light in vacuum by speed of light in medium. So particularly if they ask about define relative refractive index, you can explain. So speed in speed of light in medium by speed of light in medium 1 by speed of light in medium 2. So speed of light in medium 1 by speed of light in medium 2. Like that way. So in that way we can mention. If they ask particularly about absolute refractive index, what is the difference between absolute refractive index and refractive index? So between absolute refractive index and refractive index, the difference is, so here we are comparing with the speed of light in vacuum. So we are comparing with the speed of light in vacuum. Okay. So we are comparing with the speed of light in vacuum, okay, or air. Speed of light in vacuum or air, with speed of light in medium. So that's why this absolute refractive index. Okay, so that is a constant. So relative density you are taking, right? Relative density. What is relative density formula? Density of the substance by density of the water at 4 degrees centigrade. Density of the substance by density of the water at 4 degrees centigrade. So with the comparison of standard, okay, at 4 degrees centigrade, water will be at a water state only. Okay, so that's why we are comparing with the temperature. So that is relative density. Relative density. Here also, absolute refractive index is nothing but speed of light in vacuum or air by speed of light in medium. So this value we have to remember. So no doubt at all, this value we have to keep in mind. So 3 into 10 power 8 meter per second, there is a fixed value, speed of light in vacuum or speed of light in medium. Related to this concept, keep in mind, definitely one question will come in board exam. Definitely. This is the very sensitive concept, effective concept, easy concept. So yes, clear. So very nice concept, extraordinary concept. So one dialogue is naam chota hai, bahut lekin sound bada, like that. Okay. So here also same thing. So concept is very small, but weightage is weightage. If they ask from light reflection and diffraction, last time in the previous exams you can see in the board exam they asked about glass law. Draw the glass law. Explain of refraction through glass law they asked. So this question they will ask. It's even basic for 12th and the top 6. We may happen Huygens principle, lens maker formula. Yes, Soham. So thank you so much. Okay, done. So that's enough. So that is about the today concept. So if you have any doubts, you can ask. So if you need any classes regarding the physics, okay, so you can contact to this number. If you have any doubts, if you need any concept explanation, so if it is required, if you want, you can contact to this number 98498 So this is Siva sir from Student the Brand. So signing off. So we'll see a few more problems. Few more problems we'll discuss. Still problems are there related to this concept or different problems are there. So we do all those different problems. Okay. So 11 o'clock you can join to the class every day 11 o'clock and evening 9 p.m. Those who are new to this class, you can please do like, share and subscribe my channel. So for getting more updates, for getting more concept explanation, you can join to the class. So today, every day at 9 p.m. evening time, we'll be having live class. You have live class physics, CBSE Grade-10 physics. So you can join to the class, attend to the class. You can learn the concepts. You can ask the doubts. You can get the clarification of your doubts. So that's enough. So today, and I will sing one song. So I'll already sung that song. New Cartesian sign convention. New Cartesian sign convention. All distance measure from the pole. Distance positive along the incident rays. Distance negative opposite to incident rays. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. So thank you so much for your attendance and joining and interacting and asking doubts and so please do like and share and subscribe my channel so you can get the more content, you can get more topics explanation. If you have any doubts you can ask. So this is your Siva sir. This is your Siva sir from Student the Brand. So if you like this video, if you like this content, so you can share, you can you can spread one word regarding the student the brand. So remaining students, your friends, so they can join and attend. They can join and attend and learn the concept, right? So this is the one. This is the Siva sir. This is the student the brand signing off. Namaste. Thank you.